All right. Yeah, my name is Facundo Santiago. I'm a product manager in Azure AI. And in this topic, I want to talk about like how you make sense of it of all the models that we have available, not only in our model catalog, but in general, like right, like when let's imagine that you're starting a new a project and you want to put some AI on top of it. Like, which model do you choose? Like, with which one do you start from? And this picture that we have here is from LMCs, which measure like benchmarking across different models, right? And this image is only considering the top 20 frontier models, which is already a lot to digest, right? Like, so definitely you have some models that are like frontier models that they excel at any single task, right? So no matter what you're trying to do, they will have a good performance about that. But the question is like, do you need a model that excels at every single task that you're trying to do? Like maybe you're doing just summarization, and do you need the model that can do function calling and that can do really complex reasoning just for that? And also, like, you may have some models that even that not exceed in any single capability. They are really good at something very particular, right? So how can you make sense of all of those scenarios? And even if you consider like the latest innovations in terms of small language models, then these models that may not exceed in any single task, they are really compelling for the price that they give. Right? So if you give them a simple enough task, they will get like you a very good performance at a really compelling cost. Not only in terms of how much money you have to put to pay for each of the tokens, but also about the latency and and the speed that the model requires to generate the answer. So how can you make sense of it, right? So usually the way you approach this is like you ask yourself, like, can AI solve the problem that I want to solve, right? Because you don't want to at this moment when you're starting to develop in your project, like you don't want to start like factoring in that if you are actually using the right model. So you want to try to use the best model that is at your hands and try to see if your case can be solved using that particular model. So this is usually the phase that we call prototyping. So at this point, you're trying to assess the feasibility of the project that you're trying to do. Once you find like a model that and a way to solve the problem that you're trying to solve, and you can prove that it works to be solved, then you put like you pass to the next stage, which is what is the best model that I can use to my particular use case, right? And in this phase, what you're trying to do is optimize, right? You already proved that the problem can be solved with AI. You already proved that there is a way moving forward. So is there maybe a more efficient model that can solve that particular problem? And once you pass that phase of selecting the one that you want to optimize, then you need to learn about like not learn but like question about like, hey, what's the scale at which I need to take this application to? Because it's worth nothing if you develop a fantastic application that it works perfectly, but it costs too much to get deployed in production. So you don't really want to reach this point where you have something that you cannot move forward, right? So which are the decisions that you may take at this particular moment that may help you to take this problem and actually deploy at scale in the setting that you are looking for. So this is when the breadth of options come in, right? Like, so what we're seeing here is like the Azure AI model catalog, which is in Azure, all the breadth of models that we offer for you to get started in building applications in your ecosystem. So we have, of course, frontier models from Azure OpenAI, from Mistral, from Cohere, and also specific niche models like small language models like Pine that is also coming from Microsoft, but also open source models coming from Hugging Face, Databricks, Snowflake, right? So we have a very interesting variety of models that you can use for your applications. And something interesting about the way, at least in Azure, that we take this into consideration is like each of these models is offered through the warranties that Azure has for the customer. So data privacy is put up front, so no data is used or shared with the model providers, with OpenAI, with Mistral, with Cohere. Not any single data point is shared with them, and your data is never used for training this model, right? So you have all the warranties that Azure has. Also, in terms of security and compliance, so in terms of the SLAs that you get from these services, even with vulnerability vulnerability scanning, still hard word for me. Because that we even partner with Hidden Layer, which is a technology that allows us to scan even the model weight to look for any vulnerability that can be explored for an attacker, even at that level. Right? And then we have all the responsible AI and content safety features in terms of usually refers as guardrails to protect the answers that are getting inside of these models and also getting outside of the models, right? And something interesting for at least for the purpose of this talk is that we offer two different ways to deploy these models. One of them is go managed compute, and the other one is serverless APIs. And why this is important? So managed compute allows you to deploy these models in your own hardware, in your own compute. So you pay for the entire hardware. Maybe this is like the deployment that you're mostly used to, and you have full control of where it's running there. But we also offer a large selection of models like using these serverless APIs. And the interesting thing about this is that you don't pay for the hardware that's running under the hood. You only pay for the token. So the more you consume from a particular model, the more you pay in that particular. Why is this important? Because with a large selection of models, now if you are paid per token, you don't have any cost of switching across models, right? So you can really select the one that you really want to use for this particular task, because you are only paying for that particular consumption that you're doing there. Right? This is super nice, right? So you can select different models from different providers, but you have only one application, right? And what's something that you want to do? Like, you don't want to be changing your application each and every time because you change the model, right? Let's imagine that at some point you consider, okay, let's try Cohere Command Plus instead of Azure OpenAI GPT-4. You don't want to change all the code that you're using each time you're experimenting with this. So this is something that we took also into consideration, and this is the reason why we put a common inference schema on top of all the models that we offer. That means that you can talk with any of these models, no matter if there's Cohere, Mistral, model open source model from Fivetran. Sorry, I need to do this for the animation to see. Okay, there it is. So basically, you can use exactly the same code. Like what I'm showing here is like 3 copies of the same notebook, each of them asking a simple question about how many languages there are in the world. And I'm running these three notebooks against 3 different models, right? It's exactly the same code, and then you can see how each of these models respond to this particular question. And you also can see the difference in the stats, right, of each of these models, which is mostly related in how this model has been trained, which is kind of the consideration that they put when they build these particular models or the training data sets that were used to build these models, right? So this is important because if you really want to be able to select the best model for the best task, you need a way to switch across them without changing your code. So let's see. How can I move now? Slide. Okay, I have to do this. This is format. Okay. Let's see now a bit more concrete case about how you can put this on practice and how you can inspect an application and find out improvements scenarios to switch to a different model and actually save some money. So let's consider this simple rack scenario. So what we're trying to design here is the typical system that receives the question and will try to generate the answer. And in this particular case, we have questions about Paul Graham, and we have a data set that has information about his work, right? So in this particular implementation, we're not going to get into the details about how this was done or why we made these decisions. But in the system, the developer decided that it will be a router, try to assess how hard is the question to be answered, right? If the question is simple enough, you're going to just do a vector search using the index. And if the question is a bit more complicated, it will do a summary tree search. So the difference between these two approaches is that the vector index will just go to an index, retrieve relevant documents, and then generate an answer based on the retrieved documents. But the summary tree is going to make multiple queries, multiple retrieves. It's going to summarize each of them, and then it's going to generate an answer result. So it's really easy to see from this image that the approach at the top is much cheaper than the approach at the bottom, right? So that's why the developer probably decided, let's not use the summary tree always, because that will be super expensive. So let's put that router on the top and decide, depending on how difficult is the task, if it really works to use a complicated approach. So how can you build this using Llama Index? So I played this example. So in this notebook, we'll have the code available in a repo. What we're using is the Azure AI integration with Llama Index to instantiate two models from our hub. So we have here Cohere Command R class, which is a very powerful model, along with the embedding model that comes from Cohere, right? And what we're doing right now is building a simple index based from information that I have stored in this repository. If you see at the top, I'm configuring also the large language model we're going to be using and the embedding task. And basically, at the end, what we're doing is like executing the construction of this index, right? Everything here is kept in memory, so I don't want to get complicated into storing this information, but until here is pretty simple. And after that, what we're going to do is like tell Llama Index that we have two different search tools to perform the search. The first one is a tree summary. I explained at the top before. This is the one that executes multiple queries, then summarize them, and then generates the answer based on all of the answers. And then we have the other that is the vector index, that basically what it's doing is just execute a simple query to the index, generate the answer, and get it back. And if you see how I tell Llama Index about these tools, is I just mentioned the tool, but I also give it the description about when to use this particular tool. The first one is saying I use it when you need to summarize a question related with program and essay, and the second one, which is the simpler one, says it's useful to retrieve a specific context. Then I built this router query engine that is basically that router that you saw in my diagram, which is the piece of Llama Index that will take the decision about which approach to take. Should I take the complex one or should I take the simple one? We can see how this works here in practice. So I put one question there, like what's the summary of the document? And in this one is using the complex one. And in the second one that has like what did Paul Graham do after X, they'll have a very specific answer, right? So how can we inspect this a bit more and see how what is happening under the hood? So let's use Phoenix to understand what is going under the hood. So I need to do this. So the first thing I want to do is like to configure instrumentation, right? So you should not start developing any of these things before configuring instrumentation. In this case, I want to use Llama Index instrumentation, which has an integration with Arize, particularly with Phoenix. So the only thing I'm doing is going to launch a session from with Phoenix, and then if you see, I'm going to configure the instrumenter of Llama Index to point to the session that I use in Phoenix, right? With this thing, I am already done with all the configuration that I need to do all the instrumentation. So let's see how these results look in Phoenix. So now we're in Phoenix. So you see here some of the tests I have been doing. That was the question that I asked, right? Like, what did Paul Graham do after X? And we see also the output that was generated. But something interesting about Phoenix is that when I click on the details, I can see all the steps that were performed in this particular scenario. So we can see that the selector that I mentioned at the top, which was the router, is actually using a large language model under here, right? So we can see that LLM predict being used there. So we see that Cohere Command R class is the model that is being used in this case. And we see here the template that is used, right? Saying like some choices are given below. So like they are numbered, like so number one is the option of using summarization. Option number two is using the retriever. And then we are asking the large language model, the user make this question, can you tell me which is the most appropriate tool to use, right? So the assistant is, the model is replying, use option two. use the complex one. Sorry, in this one, use the simple one. Number two was the tool that was the simple one. So you see now how it's actually working this under a hood. And all of these problems were never transparent to you when you were writing code in Llama Index, which is also something nice. Then you can see how this continues. So it's retrieving some vectors from the document, and then finally it's going to make a request to the large language model to generate an answer based on the retrieved documents. So you see the last LLM predict. That's the second call that is being done to the large language model. But in this case, if you see, the prompt is much bigger, right? It has all the documents that were retrieved from the index, and then it asks like, hey, can you answer this particular question? And then you have there the answer. So here, like, you did nothing, right? So you configure the model at the top, and then for all the actions that the Llama Index needed the large language model to solve the task, it uses the same language model. But if you pay attention to this, the task at the top is much simpler than the task at the bottom, right? It's like this, making this choice is a much simpler task compared to reasoning about the question the user did and then trying to generate an answer. So you don't need, like, the question here is like, are you willing to pay a large language model that is trained for really complex reasoning in such a simple task? So let's see if we can do better here. So what I do here is like, let's see if I use a small language model, if I can get the same performance. So this is what I want to do now. Let's switch the model. So remember that as I mentioned at the beginning, since all the models in Azure talk the same language, like they use the same schema, I can simply change the URL and the credentials to use a different deployment. In this case, I'm using Py3 Mini, which is a small model. And now when I instantiate in the router, if I see I'm not just using defaults, I say like, by the way, use this particular model to answer the question. So once I do this, we can see what's the effect of that. I think that okay, here it is. There it is. So if I open Arize again and I see which is the model that is being used for that particular task, you see now that Py3 Mini is being used in this particular step, right? So this is how we can control which of the steps or which is the model that is used in this particular task. But now the question is like, is there any performance decrease in making this approach, right? And for that, you need an evaluation. Like you will never get away with this. So you need an evaluation in order to know if your changes that you're doing are making a difference or not. In this case, I'm using, again, Llama Index evaluations to detect, like, is the change that I'm doing something different? And in this case, I'm going to use LLM as a judge. And in this particular scenario, I really want a very powerful model, right, to be the judge, because I don't want to mess up with this. So in this case, I'm using GPT-4 to do these evaluations. And I'm using the relevance evaluation and the faithfulness evaluation. Relevance evaluation is trying to measure is the answer that I'm getting actually answers the question that the user did. And faithfulness is trying to measure is it faithful with the context that was given to this one. So here I'm configuring the workers and then running the evaluation to see which are actually measures. So if you see the outputs, right, I'm running a bit because I'm a bit out of time, as always. Let me see if I can get you the. It looks like I'm not. Okay, I cannot advance the video, but like if you see the metrics that I'm going to show there in a minute, you see that there is a drop of like 0.01 in the accuracy or the faithfulness, and there are the scores. That are the score for Py3 Mini, and if you see the scores, try to do this a bit better. For when we're using the large language model, there is just a 1% drop in the relevancy and the faithfulness. So now the question is like that does that 1% justify the cost of using a large language model? So these are the specific decisions that you can take consciously once you start to understand what is going on in your application, how your application is using each of these large language models, and trying to wonder which is the best model that I can use for each of these specific goals, and then swap that particular model in the cases that you actually so with this, I'll get to the end. Sorry for the rant at the end. But if you're interested in this code, this example is there on GitHub. So you can take a closer look at it. Thank you.
Thank you, Facundo. Great job. Q&A time. Any questions from the audience?
So you were looking at faithfulness and that stuff. What about the latency with these models? Like how much variance is there with the Phi3 versus GP4? And then also, is there a pricing difference?
Yeah, exactly. So usually it would depend on the cloud that you're using. I'll speak on the way that in Azure works, but most of the clouds work in the same way. So the pricing that you get per token is related with how big these models are. So Phi3 is small language model, so the amount of parameter that it has is way lower. Because of that, the density of models that you can put in the same hardware is much higher. Okay, so when you deploy these models, you can use much cheaper compute. So they are much cheaper in that sense, but also the speed, because the models are smaller, they run much faster.
Any other questions?
So when you were talking about routing to the different models, that was probably the first time I ever heard about that. Do you think that that's going to be like how other orchestrators are really popular and all these other things, even like load balancing, but in models and switching between them, is that something that's becoming a thing?
Well, it's definitely becoming a thing. So there's two different ways that we see the industry moving around this. The first one is like this technique that you saw here is usually referred as a query rewrite. So basically the user asks something and then you do something different. Right? You're trying to rewrite the intention of the user. There are multiple techniques about this. You may just get a question and then rephrase it completely and then retrieve something completely different from what the user asked and then try to answer. This is usually with the assumption that the user are not good at making questions, right? So just make a general question and you want to expand it a bit more to understand what is going on. This one that is routing is again one of the many techniques available, and you can solve it at two different scenarios. The first one is at the framework that you're using. This is Llama Index. This is one approach. And something interesting I'm seeing also in the industry is solving this at the proxy level. So instead of consuming these models that I was showing here, it's just we put the URL of the model and that's it. We put a proxy. And then your proxy decides which model to answer the question. This is a trend right now, but it's really easy to break today. It's there are other talks that mention this, but when you change the model, also some of your prompts may break all the way, right? So there was a talk mentioning about switching from GPT-4 to 4.0 and how that break all the application. So when you switch the model, here I just switched it because it was a simple enough task. But when you have those complex prompts with really detailed examples, with all the things, you need to think twice before changing the prompt, which is also something that is being solved in the industry. You saw the talk from ES5. They are also moving in the direction of do not worry about the prompt, just make the framework decide which is the prompt. It was kind of the thing that you saw here in Llama Index, right? We didn't write the prompt was written by the framework. So that's typically a trend I see.
Okay, we have one last question. We'll try to keep it brief.
Yeah.
Yeah, I was going to ask quickly when you started throwing other variables, or I guess take a specific example of fine tuning, which might involve data set versioning, other variables, thinking of the Azure catalog, your other parts. Yeah, how would you recommend extract the data set versioning?
Definitely, fine-tuning is also a way to induce bias. Here we saw injecting the context. If you're thinking about fine-tuning, In Azure, we have capabilities of doing fine tuning. In terms of the data set versioning, there's no any secret besides like what the typical company has been doing, right? You need to version your data sets. That will generate you a version of the model that you're running. Something interesting that you get in Azure is that when you fine tune, we don't deploy the entire model for you. We just deploy the delta. I don't know if you have heard about like LoRa fine tuning, which is an optimization that you can do. So instead of fine tuning the entire model, you just fine tune the changes that you apply to the model, and then it's much simpler to deploy for parents. I will say that. Thank you.
All right, thanks again. Big round of applause.